Another discrete probability distribution is the negative binomial distribution. So properties that are the same as those of binomial experiment, such as the experiment consists of n repeated trials. Each trial results in an outcome that may be classified as success or failure, and the probability of success, denoted by p sub 1, remain constant from trial to trial, and the repeated trials are independent. So kung mapapansin nyo, yung ating properties for negative binomial distribution is the same sa binomial distribution. So ano lang yung difference nung dalawang distribution? So trials will be repeated until a fixed number of success occur. So kapag negative binomial distribution. So for the definition, if repeated trials can result in a success with probability P and failure Q is equal to 1 minus P, then the probability that the kth success occurred on the X trial is given by, so di ba yung ating ginagamit sa binomial distribution is N at saka X, where X yung ating for example, i-determine, then yung N natin is the sample size. So dito, yung X natin, siya yung pinaka-N, then K, siya naman yung pinaka-X. So, aanin lang natin kasi baka malito tayo dun sa variable. Then, yung formula natin, halos same lang, kaso dun sa ating combination na ginagamit, so magma-minus lang tayo ng 1. So, katulad nito. So, x minus 1. So, cx minus 1. Then, multiply sa probability ng success raised to k times the probability ng failure raised to x minus k, where x is equal to k plus 1, k plus 2, up to k plus nth item. So for example, a certain drug is known to be effective in 60% of the cases in which it is used. The use of the drugs will be considered a success if it is effective in bringing some degree of relief to the patient. What is the probability that the 5th patient to experience relief is the 7th patient to receive the drug during a given week? For this example number 1, so tinatanong yung probability that the 5th patient to experience relief is the 7th patient to receive the drug during a given week. So yung identification kung paano ba natin ma-determine na yung isang specific problem ay negative binomial or any kind of discrete probability distribution. So kagaya nito, masasabi natin siya ng negative binomial or yung ating next distribution na geometric distribution since ito, yung mga 7th, 5th, so yan yung mga pwede nating maging identification. So kapag ganyan yung mga kind ng word na nasa problem, ibig sabihin siya ay negative or geometric. So, ito, 5th and 7th. Then, yung probability natin ng success is 60%. So, i-substitute lang natin dun sa ating formula. So, bali yung 7th, so ito yung ating pinaka-x. Then, 5th, yun yung ating k. K is equal to 5, then x is equal to 7. So, magiging 7 minus 1, then 5 minus 1, or 6c4, multiply sa 0.6 raised to. So, same pa din dun sa binomial yung ating magiging exponent. Hindi tayo magbabago. 0.6 raised to 5 times 1 minus 0.6 is 0.4 raised to 7 minus 5 or 2. So, ibig sabihin, 6c4 times 0.6 raised to 5 times 0.4 raised to 2. So, ang probability na yung 5th patient to experience relief is the 7th patient to receive the drug is 18.66% or 0.1866. So, yun yung answer natin for this example number 1. Example number 2. So, find the probability that a person tossing 3 coins will get either all head or all tails for the second time on the fifth toes. So, kagaya niyan. So, second time on the fifth toes, ibig sabihin siya ay negative binomial distribution. Pero kukunin muna natin yung probability. So, ano ba yung probability na kapag nag-toast ka ng 3 coin, pwede kang makakuha ng either all head or all tails. So, gawa tayo ng gawa kayo ng tree diagram para mas madali nating ma-determine yung probability or number of sample points. So, yung magiging tree diagram natin, so first experiment or first toes, so head and tail, then sunod dun sa head, tail, then another head, tail, and head, tail. So, ibig sabihin meron tayong HHH, HHT, HTH, HTT, THH, HT, then TTH, and TTT. So, ibig sabihin meron tayong 8 sample points. Ilan ba dun yung ating all head and all tail? So, meron tayong isang HHH at isang TTT. So, ibig sabihin, dalawa over sa total nating sample na 8 or 2 over 8 or 1/4 or 0.25 or 25%. So, yun yung probability natin. Then, substitute lang natin dun sa ating formula. So, fifth toes, then second time, so 5 minus 1 and 2 minus 1. So, ibig sabihin, for C1 times 0.25 raised to, so same pa din yung exponent, kagaya ng sa binomial, raised to 2, times 0.75, since 1 minus 0.25 is 0.75, raised to 5 minus 2. Or for C1 times 0.25 raised to 2, times 0.75 raised to 5 minus 2. Or yung answer natin is 0.1055, so sa calculator, or equal to 10.55%. So yun yung answer natin for example number 2. So madali lang naman yung negative binomial distribution. Another discrete probability distribution is the geometric distribution. So itong geometric distribution is the special case of negative distribution where always k is equal to 1. So kapag ang ating k ay equal to 1, so geometric distribution na. So same, parang na-derive lang yung formula niya dun sa ating negative binomial distribution. Kaya lang, yung kapag geometric nga, ang k niya ay laging 1. So, ibig sabihin, pag ang problem ay parang negative binomial, then ang k niya ay equals to 1, pwede mong i-apply si negative binomial at saka si geometric distribution. Pero, kapag sinubstitute mo sa formula, ito lang din yung lalabas na formula. The probability ng success or P multiply sa the probability ng failure Q raised to exponent natin is x minus 1 or x minus k, since k is equal to 1, where x is equal to 1, 2, 3 up to nth item. So, proceed tayo sa example ng geometric. So, example number 1, in a certain manufacturing process, it is known that on the average, 1 in every 100 item is defective. What is the probability that the fifth item inspected is the first defective item found? So, kagaya niyan, pwede mong i-apply si negative binomial distribution where x is equal to 5 since fifth item, then k is equal to 1 or the first defective. Kaya lang, kapag in-apply mo si negative binomial distribution, so yung ating ginagawa for combination na k minus 1, so 1 minus 1 is 0, so automatic yung value niya is 1 pa din. Kaya pwede na natin siyang i-disregard. Kaya ang magiging formula na lang natin is P times Q raised to x minus 1. So ano ba yung ating probability ng success? So 1 in every 100 items, ibig sabihin 1 over 100 or 0.01. Then, ang probability natin ng Q is 1 minus 0.01 or 0.99. So 0.1 or 0.01 times 0.99 raised to ang ating x natin is 5, 5 minus 1, or ang exponent natin is 4. Ilagay na lang din natin yung magiging solution. So, bali yung probability natin or P na 0.01 multiply sa Q natin na 0.99. Then, raise natin sa 5 minus 1 or 4. So, kapag sinolve natin siya sa calculator, ang lalabas ay 9.61 times 10 to the negative 3 or 0.0096. So, yan yung ating answer for example number 1. So, proceed tayo sa example number 2. Find the probability that a person flipping a coin get the first head on the fourth flip. So, yon. Ang K natin is first head and X natin ay fourth flip. So, ano yung probability na flipping a coin? So, ibig sabihin, isang coin, ang ating outcome ay head and tail. So, ibig sabihin, yung probability na lalabas yung head is 50% and also yung sa tail na 50%. Kaya ang P natin ay 0.5. So, 0.5 na P. Then, ang Q natin, syempre, 0.5 din. I-raise lang natin siya sa 4 minus 1. O magiging equal siya sa 0.5 times 0.5 raised to 3. So, ang answer natin for example number 2 is 0.0625 or 6.25%. So, madali lang din yung geometric distribution. So, proceed tayo sa example number 3. The probability that a student pilot passes the written test for his private pilot license is 70%. So, find the probability that a person passes the test on the third try. So, ano daw yung probability na yung person? So, a person, so ibig sabihin meaning isa lang, ay makakapasa dun sa test on the third try. So, x natin is equal to 3. So, ang probability natin is 0.7. So, equal 0.7. Ang Q natin is 0.3. I-raise lang natin sa 3 minus 1. So, using calculator, so, ang lalabas na answer is 0.063 or 6.3%. So, yan yung answer natin for example number 3. So, madali lang or parang same lang si negative binomial distribution at saka si geometric distribution.